Okay, so today we are going to talk about store procedures and triggers. Okay, so as of now, what we have learned so far about the various objects of SQL Server, where we talked about views, we talked about functions. In functions, we talked about use the inline function, the multi-statement table value function, and also the scalar function. Apart from that, we also learned the various type of control flow statements that we use in all these objects. So today the topic, first of all, we'll talk about the different database programming concepts. After that, we'll talk about store procedure, and because store procedure and triggers are similar, we'll talk about trigger as well. Now, talking about the database programming, we have two types of component that comes in the database programming, and these two components we use in almost all the store procedures that we create. So these two components are variable and control of flow tools. So talking about the variables, yesterday also we created some of the variables while we were doing some of the operations, like trying to write some if statement, some case statement and things like that. In that process, we created some variables as well. So similarly, if you want to declare a variable, the way to declare the variable is declare then the variable name. And after that, you mention the data type of that variable, like this is of the money type. If you suppose that you want to declare two variables together or more than two variables, you can also write one declare statement, and then comma separated you can write multiple variable names as well. So this is how we declare a variable. Assigning the value to the variable, again there are multiple ways of doing that. Suppose that you want to declare each variable one by one, then you can also assign the value to the variable in the same line. Like after declaring the variable name, then the data type, after that you can use equal to, then the value of the variable. Another way of doing that is we can use the set statement, where we can use the set, then the variable name, and then after that equal to clause, and then the value. So this is another way. Suppose that if you want to declare the value of the variable in the next line. So talking about also how can you define, how can you assign value to a variable in a select statement, that is also possible. So suppose that you want to get the value of the variable from some table, right? You have defined a variable, but the value of the variable would be coming from some table. That is what sometimes the requirement is, because sometimes you want to get some value and then do some operation on those values which is existing in the table. So in that case, this assigned to a value into a variable into select statement. If you want to do that, then you write select the variable name, and after that equal to, then what is the value that you are selecting. The only constant here is that when you are writing such a statement, make sure that the, because this variables is a scalar thing, right? It can just hold up only one value. So make sure that whatever query you have written, that should return only one value. It's not return more than that. Because if that would be the case, in that case, the select statement would fail, right? So there should be exactly one record here where the price from titles, where the title ID is this. So there should be exactly one record for this title ID. If there is more than one record, then this variable would not be able to hold that information, and this statement would fail. So, so when you are using the variable in the select statement, you have to pay attention in this part. Now, talking about the store procedure, we'll cover three things. First is what is a store procedure? Why do we need the store procedure? That is, what is the difference between using a store procedure versus a normal SQL statement? Because whatever you do using the store procedure, you can do that using the normal SQL statement as well. Then why do we need the store procedure? The third one is the how do we create the store procedure? How do we update the store procedure? And how do we delete the store procedure? So talking about first, what is a store procedure? A store procedure is a collection of T-SQL statements that SQL Server compiles into a single execution plan. What does it mean? It means is that what happens is that the SQL Server, it binds all those statements. Suppose that you have created a store procedure. The number of lines of code of that store procedure is around 200, 300, right? What SQL Server would do is that it would bind all those lines of code into one single statement. It would compile them like that, that it is just one single component, right? So that is what happens when you create the store procedure. And also, the main important thing is that it is compiled as a single execution plan. Now, what is the execution plan? Execution plan is a method which is used by SQL Server to execute a query. Whenever you execute a query, that query, first the thing happens is that while processing of the query is that an execution plan is created. Execution plan SQL Server creates that it defines how it is going to create the how it is going to give the result, like what are the components it is going to use, what are the different physical operators it is going to execute that query. That is what the execution plan. So when we define a store procedure, that is execution plan is stored. That doesn't happen in a normal T-SQL statement, and that is why we should be creating the store procedure. So because if the execution plan is already stored, that statement would be faster than a normal T-SQL statement. That means if you execute normal T-SQL statement versus executing the store procedure, which has the same statement, execute the store procedure would execute faster because it is already compiled and stored as a single execution plan. The second part of it is procedure is stored in cache area of memory when the store procedure is first executed, so that it can be used repeatedly. SQL Server does not have to recompile it every time the store procedure is run. So that is the second part of it. So what happens is that also the procedure is stored in the cache area. That means when you define a store procedure and you create it, a a cache in the cache area of the memory, the store procedure is like its plan is actually stored there, right? So also suppose that you didn't do any changes in the store procedure and you're using it again and again, right? Then the when you execute the statement, the first part of the execution is compilation of it, so that it can find if there's any syntax error, any what is the way the query should be executed and things like that. So those part of the things could not happen in the case of procedure. While in normal T-SQL statement, the compilation would happen if suppose that you execute those T-SQL statement 100 times, compilation would happen all those 100 times. But in a store procedure, the compilation would happen only the first time. And after that, that compilation process would be skipped. And that's again another reason why the store procedure should be created, because it reduces that time to compile the query all the time, right? So that's why when you create the store procedure, the first time execution would be slower, but from the subsequent execution, like likewise like the second execution onwards, the execution would be faster. Also, what are the other properties of store procedure? The store procedure can accept input parameters, it can return output values as parameters, or return success or failure status messages. So these are the three things that a store procedure can do. It can accept some parameters, it can also return some output values as parameters, and also it can return some success or failure status messages. Now let's understand from a diagram perspective what is the difference between a SQL statement and a store procedure. So see, when you create the store procedure, the first thing that you do is that you create it, right? In that the syntax is checked and the procedure is also compiled. Then also you execute it for the first time, then it would execute and return the data. From the second time, what would happen is that it would just execute and return the data. The checking syntax part and the compilation is skipped, right? While in the normal T-SQL statement or T-SQL statement, what would happen is that when you execute the query the first time, definitely the syntax would be checked, the compilation would happen, the execution will happen, and then the data would be returned. When will you will again execute it the second time, the same process would be followed. There will be no changes. Whereas in the store procedure, from the second time onwards, we are not going to check the syntax, or we are not going to do the compilation. The compilation would only happen suppose that you have added some new things to the store procedure, you have altered the store procedure. In that case, compilation is important just to check whether the query that you have added or removed is it again true or not, like it's correct or not. So for that, again, the compilation would happen. But that is something that we don't do all the time. Not every time you will, change something in the store procedure. If that is what something you are doing, you should be going with the normal SQL statement, because you won't be getting any benefit by creating the store procedure as well. So this is the major difference between the SQL statement and the store procedures. And again, in the interviews also, this question is asked a lot of times. Now, talking about the various things that we are going to do now is that we will understand how do we create a store procedure, what is the syntax for that, how do we update a store procedure, suppose that we have created a store procedure, how to make changes to it, and then how do we remove the store procedure from the database. So talking about creating a store procedure. So creating the store procedure, there are various type of syntaxes that we can have. One is without parameters. We can also create a store procedure without parameters, which is not a useful a lot, right? Creating a store procedure without parameters is not very useful. Still, you should be creating a view. So also when we talk about what is the difference between a view and a store procedure, so we say that a view is a store procedure without a parameter, which is correct. So instead of creating a store procedure without a parameter, you should go for creating a view in such scenarios. And then the second one is the example where which is the mostly used thing about the store procedure. So we create the store procedure with the parameter. Now the parameter can be the input or the output, depending upon your requirement. And third is the using return statement. You can also use the return statement in the store procedure if you want to return the control from somewhere. Now talking about the syntax of a store procedure. So the syntax of a store procedure is again like as you can see here, either we can use uh, create store procedure, procedure name, and then the parameter name, and then the data type. You can also put some default value to the parameter. That means if some value is not provided by the user, then SQL Server can use that default value to execute the store procedure. After that, there is a as clause, and then again, if you remember yesterday, we talked about begin and, though it's totally optional to use that, but every time when I create the store procedure, I use the begin end because it helps me to understand that from where the body of the procedure has started and where it is ending. Okay, so this is how the syntax of the uh, store procedure look like. So going to next, let's talk about one of the example. So this is an example of creating a store procedure. Now this store procedure does not have any parameter, right? So this is the first example that we talked about, store procedure without a parameter. So here in this store procedure, what we are doing is that we are just creating a store procedure, right? But we are not doing anything that could make a difference between a store procedure and a view. So this thing again you can do using a view as well. You don't need a store procedure in this scenario. But again, as we have this flexibility, so that's why we can create a store procedure without a parameter. But again, as I said, we don't use this scenario a lot, right? This type of scenario is not used a lot. The second example is that you create the store procedure and use the input parameter, right? So when you use the input parameter, then you should also be using that input parameter somewhere in the logic of the store procedure. So like here, I have defined the input parameter. I am using that parameter in the select statement of the store procedure. So that actually that is how the store procedure should be created. Now let's go back and let's understand how do we create a stored procedure. Maybe we'll create it the AdventureWorks 2017 database. So I'll just open the table viewer so that I can see the table. So create. So either I can write proc. Okay. So this would also work, or you can write procedure. So you can either write create PROC or procedure both. Both will work. Okay. Then name of the store procedure. PR underscore, suppose that human resources details. Okay. Now here, as of now, I don't think we have done 4 5 table join. But now in this query, I'll use like at least 3 4 tables. So let's take let's take a parameter as business entity ID, right? So this is one of the input parameters, and give it a data type as well. And then after that, use as, and then I always use this beginning because that gives me, a better way to. This is where I'm going to use this to. Now there's a thing called SQL injection. I don't know whether any of you have heard about this or not, but SQL injection is very common, and that also happen. A lot of people don't think about that when they create the store procedure. But as we are creating here, we should always, use make consideration of the SQL injection. So we can also avoid the SQL injection as well. So how can we avoid the SQL injection? We can define our own local variables. So declare at the rate business entity ID underscore local in set business entity ID local equal to business entity ID. Now this way I have avoided SQL injection. Now I'll write initially I'll write select star from because I want to use this intelligence dot employee e join human resources dot department d. No, I will use department history. Department history ed h on e dot business entity id equal to edh dot entity id. Join department d on d dot department ID equal to edh dot department ID. Join human resources dot employee pay history EPH on EPH dot business entity ID equal to E dot business entity ID. Join human resources dot job candidate on, give it a name, J dot business entity ID equal to E dot business entity ID. Join human resources dot shift S on S dot shift ID equal to J dot. Okay, where do we have the shift information? EPH dot, we don't have shift here. E dot. Okay, so I'm not getting any particular information for shift. So the other way to find that is that just go there and see if there's any linkage between this uh, shift to any of the. So do we have any keys here. So as you can see, there's no key, right? The other information, like you must be thinking that how did I join all these tables? That is very easy. If you have existing table that is there, what you can do, you can expand it and you can see the keys here, right? Similarly, I can expand, I can see the keys here. If you see here, so we have some foreign keys here. So that is how the relationship is there between multiple tables. If you see here, you would see a foreign key to the employee table as well. This, and then we have this in the EDS. We have the shift ID as well, right? So this is how we can join s dot cd equal to EDS dot shift ID. Now we have joined all the tables in which is the in the so similarly, if you want to join more tables, you can join from the DB. And this is how you should be writing the join. You can just take care of how the keys are related and all. Once you see that information, you can easily join any number of tables. And in the normal scenario, you will see at least 5 or 10 tables joined together to get some information. Now if I run this query on my own, I got this data, just two records, right? Now what I will do is that I will, because here I have to pass some parameter as the business entity ID. So I'll use this whatever I have defined locally. I should not be using this because this can cause some SQL injection problem. Yes, Shweta.
Um, can you explain this joining of tables here? Anup,
Okay.
I'm not
Okay.
clear in this scenario.
Sure. I will explain. Okay. So as of now, my query is completed. Let me explain the joins here. Okay. Let me make the query better as well because right now, even I'm not liking the query. So this is how we should be writing the query. Just to Just give me a second. Let me fix the query. It should be better readable whenever we write the query. So we should be writing each join on a next line so that it's visible clearly which of the tables we are using and all. Okay. So now the query looks better. So okay. So how we are using all these joins? Now the first thing I guess that everyone of you knows that we are using the inner join here. Inner join, what it does is that it only takes the matching records from both the tables. Okay, if something is not matching, it will avoid that thing. It will not display that. And that's why we are just getting two records. These two records are there in all of these tables. And that's why we are getting these two records. Now, how are we using this join? Now, something is from the coming from the naming convention. That's why I was pretty sure that this information would be there in this table. While some of this is coming from the keys relationship. The last join that I did, this came by after I looked into the foreign key relationship of this table because I was not able to find the shift ID on my own, right? So you must have seen that. Now talking about the first thing. So suppose that this is the employee table and this is the employee department history table. So whenever we try to join the tables, two tables, we try to join it on the basis of the primary keys of the table. That is the best candidate for joining two tables. If you are not able to find any relationship using the primary key, then only you should be using some other key, right? But here, because employee and employee department history, so just think like this way: what the employee department history contains, and this is again coming from the naming convention. In real life scenarios, you'll find tables like this only. You will not find that the employee department history is stored as something like DH. That would not be the table name. The table would be clear. It would show that what this table is holding, right? And that's why naming conventions are very important. I took a class on naming convention because I wanted you to tell all of you that this is very important concept and we should pay some attention to it. Now, how I use this join? So because employee department history was there, so definitely this is talking about the department history of the employee. So I thought that definitely it would have some employee constant. Now, if you want to store in some other table some employee related data, what is the thing that you use from the employee table? Definitely the business entity ID. And why so? Because this is the primary key. So when you use the primary key in another table, it becomes the foreign key. And that's why we should be looking whenever we are joining the join condition between two tables should be on the basis of the primary key. So I was already looking into the name of this table. I was pretty sure that definitely because business entity ID is the primary key of this table, so definitely that information would be here because its name is like employee department history. It stores the department history of the employee. And that's why I just started just typing this business entity ID, and when I went to EDH, which is this department history, I got this business entity ID there as well. Now this join is completed. The next table that I saw here, what should I join here? So I have the employee, I have the employee department history. Now in the employee department history, there definitely there will be some department related information. So what is the next table that I can join? Just I saw from here, and then I choose the department. So in the department, definitely we have the department ID is the primary key. So we can use the same department ID and we can again join back to this table. And this is what we are doing here. Coming to the next table, we have the employee pay history. We have all these six tables in the human resources schema that I wanted to join. It's not like that you can't join any table from the other schema. We can do that as well. Like because there's some relationship between these tables as well. If you see here, there's a relationship between person. There's a business entity ID column in the person as well. So you can join employee to person as well. You can do that as well. But talking about this, next table was the employee pay history. Again, it's talk about the employee payment history. That means it definitely has the employee ID column. That means the business entity ID column. And that's how I joined this on the basis of business entity ID column. The second, next one was the candidate. Now, this was little bit complex, but when I saw the table, right, when I saw the description of the table, or just when I clicked here, J dot, then I saw this business entity ID popping up. So that's how I got that. Definitely then this business entity ID is the same thing as the employee ID because that's how we name the things. If it's the same column, we try to keep the same column name in all the tables that we use. And that's how I joined this again back to the employee table. If you don't want, you can also use the employee pay history table here. So that would mean the same thing because all of these are inner join. It doesn't mean that you have to always use e.business. Even if I use eps.business entity ID, I would get the same result. I can show you that as well. So that is not important that from which table are you joining the moon because it's all inner join, right? There would be no difference at all. Next is the shift. In shift, I found some difficulty because I got the shift ID. Again, why use the shift ID? Because if you see the shift table, the other things are literally name, start date, end time. These are not the good candidate for joining the tables. We should try to join the tables mostly on the integer columns. If integer columns are not present as a relationship, then only we should go for names, etc. to join the table. So that's why I used in the shift ID. Then I started looking for where can I get the shift ID. Then when I looked into the other table, I got in the employee department history, I got the shift ID. And that's how I joined the shift to the employee department history shift ID. Suppose that this shift ID is also in the pay history, we can use that eph.shift ID, but that is not there. It's just there. So that's why I used that one. Sweta, did you got it?
Yes, yes. Thanks.
Okay. Okay. So now, after that, we have the where clause in which we are using this business entity ID local. Why we are using this local variable? Because we want to avoid any SQL injection. And always you should be trying to, whatever the parameters that you have in your store procedure, you should try to define a local variable for that and using that variable instead, right? Now we are using a lot of here I'm using a star. You can see a lot of values coming here, but I don't need all of them. What I need is that I just need two columns. So what I'll do is that I'll start taking those columns instead of select a star, select E dot birth date, E dot. Okay. So as you can see, there's no name of the employee. You don't see the name information of the employee. With all that I explained just now, can anybody tell where can I find the name of the employee? What would be the best table to store the name with this background? I want to see the name of the employees as well.
Job candidate.
Mm, Job
Oh,
candidate, though, I don't think because it would be mostly about the job. If we don't have it in the employee table, which most of the time we try to keep the names in the employee table. If it's not there, then we should go to the employee table and we can see that what are the different tables we are joining it. So I see a table named person. Then I'm pretty sure this person table would be holding this name information. So what I do here is that I'll join that person table now. Join um, person dot person. Now this table is in another schema. I'll give it a name P on P dot. Again, we have the business entity ID, right? Equal to E dot business entity ID. So I joined the person table now. Now let's see if we have a name of the person in the person table. P dot C. I have the first name plus P dot middle name plus P dot last name as name. Here also, if we won't give the space, it will not consider it. So we should also give some space. So this is the name of the person. Now, what else I want? E dot birth date, E dot gender, E dot hire date. Then from EDH, I want. So why I used a lot of tables here in the join because I want to get information from all these tables. That's why am using all these tables. Otherwise, there's no purpose. So D dot um, group name, D dot name. Now this table I have given name, this column I have given name. This is again returning name. This can give error here. So that's why I should rename it as department name because it's coming from department. And here I can also write employee name, and then I'll some use why I'm using a lot of columns here just to explain you that why uh, like what the normal scenario looks like. EPS dot rate, EPS dot pay frequency. So this is the employee pay history is coming from this table. Then we have the shift table. So for that S dot name, this is giving the shift name. S dot start time, S dot end time. So this is all the information I wanted to fetch from this table. So I've created a stored procedure where I'm getting all the employee related information, right? And with this thing, now I can just create the stored procedure. So I'll just run this execute statement here, and this stored procedure is created. Now, if you want to execute this stored procedure, what is the thing that you have to do is that you have to just use the execute name of the procedure and then the parameter value. So what we are using here is the business entity ID. So I saw 274 was one of the business for which we got the values. I'll use the same. And if I'll execute, I can see the name of the employees. If it had first name, middle name and last name, what I did is that I concatenated all of them. Then this is his birthday, this is the gender, this is the hire date, this is the group name, this is the department name, this is the rate, this is the pay frequency, this is shift name, and this is the time of the starting of shift, and this is the end time of shift, right? If some value is not existing, it would all return any value there. Like for example, I just run it for 101. I'm not getting. Another way to execute this query is that I can use exec also. So that should also, do the same thing. I saw one more value 212 which was returning, so I can see that as well, right? So this is how we create the store procedure. This is a, I would say, basic store procedure because it doesn't have a lot of line. What we also can use is that we can use a while statement, we can use the if statement, and things like that, depending upon the requirement, right? So, but the basic structure would be like this only. This is how we'd be creating the store procedure. Now, going further, we can also use the return statement in the store procedure. So return statement, suppose that if employee code you have given as null, right? You are not passed any employee code in this procedure. So sometimes if some value is null, you just want to, return an error. You don't want to execute that procedure. Then in that case, you can use the return statement, because when you use the return statement, if the control comes there, it will just return from there. The store procedure execution will be stopped only there. So for example, you wanted a scenario here again, that if the business entity ID is null, right? In that case, what should we do? So I can just add extra thing here. And for that, I need to alter this store procedure as well. What I can do, I can just copy the thing from here. And this logic again, I can use in my procedure as well. And here, instead of this, I should be using business entity ID. And if I do this, what will happen if I don't pass any business entity ID? In that scenario, SQL Server would, or that means that if I pass it as null, if this value is null, then what will happen? Uh, that it will just give this message and return come out of the control. It will not go to these statements, all this, right? So let me alter the store procedure and show you. So this store procedure is definition is changed. I have altered it, right? So I've added this logic there. Now let me go back and give the null. So see, I'm getting the message. Please enter employee code. And if I give an employee code here, then I'll not get this message. And because the if would only be executed when this would be true. Right now I have put a value, so that's why it's just going here. The control is just checking this, after that going here. It is not coming inside this. So that's why I'm getting the value here. Now we have just talked about creating the store procedure. There's another type of store procedure that we can create, right? And that store procedure is like creating a store procedure with the output variable, out output parameter or variable, whatever you want to say, right? So we can create the store procedure with the output parameter as well. So let me give you example. I'll create a short procedure this time because the plan is to just get how do we create a store procedure with the output parameter and when do we require it. So create procedure PR underscore employee details, and then suppose that gender were at 20. We were using gender, right? Employee. So see, after looking into the data size, I just changed it to char one because I'm pretty sure that gender would be the just one character. And then maybe I'd use employee count. and I'd also guess int and output. Now this is the output variable. What what is the purpose of the output variable? The output variable actually it makes sure that um, using this output variable, if you want to return something from the inside of the store procedure, if you want to do some logic and then want to return something from inside the store procedure, then in that case you should be using the output variable. Though the use case is just 95% of the time you'd be not using this output variable, but there are 5% of the scenario when we use that. In the normal business scenario, like I would say that 95% of the time you won't be using this output variable at all. So what I'm going to do is that again the next thing is that I'll just get this value of the output variable as count business entity ID from human resources dot employee where gender equal to at the gender equal to at the rate gender, right? And then so this is the procedure that I'm creating. What it would return is that it would count, give the count of the employees from the human resources dot employee pair whose gender equal to the value that I have provided for the gender. So I'll just create this is procedure. This is created now, but there's a thing. How do we execute this stroke procedure? Because this is having an output parameter. When a procedure is having output parameter, in that case, the execution is not like normally I can't write here execute procedure and then keep the value of the gender. That is not how it would work here. So for executing this stroke procedure, first of all, what I need to do is that need to declare a local variable here. And this is how we avoid SQL injection mm, for the output variable. So employee total, maybe something like that, and give it a value int. Now this data type should be similar to what we are using here. So I have declared a same variable with maybe another name, or I could have used the same name, but I have declared this variable here just to get that information. So then execute the name of the store procedure, which is this, right? And after that, I'll pass the parameter. Suppose that I want to get the count of the female employees. And then I need to use this employee table, whatever I have defined here, and give it a name output. Because this is how the structure of this procedure looks like. What I have defined is the local variable here, because this variable is again local to here. And this is the output variable. So I can't pass a value, but I have to use something which can substitute this variable. And then I have used this employee. Now this employee total, because this employee total is what it is showing is the employee count. So it will just get the count here, and then I can select the count. So I can print it or select it, whatever I want. So print this employee total. So this is how you run a store procedure which is having the output clause or output variable, right? So when I'll execute, what I'll get is that I'll get the count of the employees whose gender is female. All right. Let me run this. So I got 84. I can also do this as select. So any idea what is the difference between using select here and the message here? I have shown you one by one. Did anyone notice what is the difference?
Column name.
Maybe the name of the column.
No. The difference between using select and print here is that, and I had told before as that when I had used print in some previous instances as well. When we use print, right? When I use print here, that information would be coming in this messages part, this messages tab. When I use select, that would be coming in the results part. That is the major difference between using print and select. So if I again run using print, see, this is coming as a messages, right? When I'll use select, then this is coming as a in results. And also you can give some alias here. Mm, wow. So now we have the value of this column as well as employee. So this is how we use the so if you want to do some complex operation and that finally as the result and you want to get some single value, in that scenario you should be using the output condition. As I said, 95% of the times we don't use this output, right? This is again some complex level of thing, and this is not a simple thing to do. So 95% of times you won't be using the, or even I can say 98% of times you won't be using this output clause as well. But it's important to understand everything while we are learning. That's why I've covered that as well. Now talking about the update, while I was writing the store procedure, I already covered this. I used the alter statement to update the store procedure, right? I'll be giving some assignments also on creating some store procedure. I'll give you some business logic from the same AdventureWorks database, and you have to create some store procedure, right? Then suppose that you have used the store procedure. How do you drop the store procedure? So for dropping a store procedure, what you use is that drop procedure name. So if suppose that I want to drop this procedure, then you will drop procedure, then name of the procedure, and command completed successfully. My this procedure is just dropped from the database. The next part is trigger. What is a trigger? So this is all we are going to talk about. What is a trigger? What is the create syntax? What is how do we disable or enable a trigger? Then deleted and inserted tables, example, and other things. Now, trigger is not very useful now. There are many alternatives of trigger now with SQL Server 2019 in place. And we try to avoid triggers because triggers can cause performance issues in the databases. Why? Because triggers, you don't run the triggers manually. Like in the store procedure, we run the store procedure manually, but triggers you don't run manually. And that's the major difference between the store procedure and a trigger. So a trigger is a special type of store procedure that is executed automatically as part of a data modification. So whenever you do insert, update, or delete, in that condition, you can define a trigger and then that trigger will be fired automatically. A trigger is created on a table and associated with one or more actions linked with the data modification. When one of the actions for which trigger is defined occurs, the trigger fires automatically. Following are the main examples of trigger usage. When we try to maintain the duplicate and derived data, so suppose that you're trying to insert some duplicate data and then you can define trigger. That trigger would check if that data which you are trying to insert is a duplicate data or it's good data. Then accordingly, it can just take care of that, whether to insert that data or not. Some complex column constraints in that case also we use the triggers for cascading referential integrity. So for example, if you are inserting something in the employee table at the same time, you want to insert some data in the employee pay history table as well. So if you want to do such type of operations automatically, you can define a trigger. And in that trigger, you can just define it on the insert statement that whenever you are inserting something on the employee table, then run this logic. In that logic, you can just write the insert statement for the employee pay history table. And then also for the same thing you can do for inter database as well. That is from one database to another database if you want to make some changes on the basis of some DML operations. The syntax here is a little bit different. The SQL statement part is just the same. The syntax is in the beginning is a little bit different. So you define like there you were defining create procedure name. Here you write create trigger name. Then here the important thing is on that on which table are you creating the trigger. This is the most important thing here. So After that, you define for or after. Now that depends, like that when you want to do that operation, which means here that suppose that you insert it in one table. So do you want to insert in another table after the record is inserted the table, or there's a thing called instead of trigger as well. So instead of runs that, if you suppose that if I there's a insert table in the employee table, right? So in that case, I want that if any insert statement uh, comes in the employee table, so using instead of inserting the in the employee table, we should be inserting in the some other table, maybe the employee pay history table, something like that if we want. So we in that case we can use the instead of trigger. And then after that, these are the three major operations: delete, insert, update, on which you define the trigger. Now, when you create the trigger, sometimes we don't want to use it as well. And that's why we have a special syntax for disabling and enabling the trigger. So to disable the trigger, I'd use disable trigger trigger name on table name. On table name is important because on one table there can be multiple triggers as well. And that's why there's a on clause here. The same way to enable the trigger, you just use the enable trigger trigger name and then on the table name. Now, how trigger keeps track of all these deletion insertions that we are doing from one table to another. So there's a concept called magic table, and sometimes in the interviewer asks you that what is a magic table? What do you know about the magic table? So the trigger work in such a way that they store all the information in the magic tables. There are two tables. One is the inserted table and second is the deleted table. These are the two tables known as the magic table, which are used to in the triggers internally. Take to make sure that everything that we are doing are able to be tracked. So when you create a trigger, you have access to two temporary tables, the deleted and the inserted tables. They are referred to as tables, but they are different from two true database tables. They are stored in memory, not on disk. So one of the important thing about these magic tables are that these are stored in disk, not the memory, right? So that is the major difference. Now, uh, let me change the color here. Okay. So these two magic tables, that the inserted and the deleted tables, they are stored in the memory. It is not stored in disk. While the tables that you create, they are stored in the disk. When we insert, update, or delete, when a insert statement or delete statement is executed, all data will be copied into these tables with the same structure. So these tables are created automatically in the memory and they have the same structure. That means all the same data types and columns as the base table. So that happens only for the tables on which you have created the trigger. And that's why when we create the trigger, we define this on table name. That means this is the table on which the magic table would be created. So depending upon, suppose that you want to insert the data. So you can just, that data would be there in the inserted table. When you delete the data, that data would be there in the deleted table. But what if you update the data? Updating means changing something in the current record. So that means the new data would be there in the inserted table, the old data would be there in the deleted table. So when we do the update, when we do the triggering on the update, in that case, both the magic table holds some information. The inserted table holds the new information while the deleted table holds the old information. The value in the inserted and deleted tables are accessible only within the trigger. Once the trigger is completed, these tables are no longer accessible. So when this trigger is created and fired, then only at that time only these two tables are being accessible. And after that, these two tables are dropped automatically by SQL Server. So let me take an example here, right? Suppose that when you are doing any update on this bicycle inventory table, right? There's a table name. Then you want to print a message to the user that there's some you have this bicycle inventory table was updated, right? Just to take an example here from other perspective, because I'm not very advocate of creating the triggers and all, but just to explain this, because I don't like triggers because of the other problems that they cause related to performance tuning and all. So suppose that you create a trigger name, uh, employee insert message, something like that, on human resources dot employee, right? For update, print the human resources dot employee table was updated. Again, you can use the begin in just for better, right? So once you created this trigger, okay, the problem here is this string. So now this trigger is created, right? So suppose that I do some update in some of the value of this table. So update uh, human resource dot employee. Let me also check the value first. Select top 10 star from human resources dot employee. Set job title equal to system engineer, where business entity ID equal to 6. So what I'm trying to do is that I'm trying to update the job title of this person to from design engineer to the to the system engineer. I'll just run this update statement. See, I when I run this statement, what I got this, the human resources dot employee table was updated. From where I got this? Because I didn't run this trigger. What happened is that I have kept this trigger on this table for update. So whenever any update will happen in this table, this trigger would be fired automatically. Now here I have just used a print message. What I can do is that I can do anything here. I can use insert statement, delete statement, update statement, select statement, whatever I want to do, I can do all this logic here depending upon the situation, right? So just try to understand that this trigger, it gets fired automatically depending upon the logic that I have used. So I've used it on the update and the trigger is defined on update. I can do it on insert as well. I can define the trigger like this as well. So it will then fired on update and insert both, right? So accordingly, you can define a trigger and you can see the value also. The value has been updated. We got the message, but it has been updated as well, right? So this is the meaning of the trigger. The trigger is used to, to also the thing for which you use the trigger. Like here, I used for the update. That is called as the triggering point. That means what is the DML statement on which you are trying to fire the trigger. And the trigger, you don't execute it. It gets executed automatically when the situation is met. Like here, when I try to update something in the employee table, this trigger got fired automatically. We didn't need to execute this. And we have just written a print messages here, and that's why just that was printed. If we have used something else, then that could have been printed. And we have defined it for update as of now. If we do insert or delete, nothing will happen. This trigger won't be fired. It would only fire on this update statement. So now if you want to see what is the content of a trigger, right? Or what is the content of a store procedure? What is the content, right? So you can use this sp underscore help text. So to see the definition of any object. That is valid for trigger, that is valid for procedures as well. But if you want to see what are the numbers of triggers that are created in the, on a table, then you can write sp underscore help trigger and you can use the table name. In that case, you will be able to see what are the different type of triggers which are defined on the on this table. Now, if you remember, I also talked about how can we disable the trigger. So if you want to disable the trigger that I just created, then disable trigger name on table name. This is what we use. So I'll just use this statement. I'll disable this trigger because I don't want this trigger to be there. Disable trigger. Also, we can drop the trigger. So it's not like that we can drop it. Trigger name on table. So this is done. Now this trigger is disabled. So what if I use the same update statement now here? Suppose that I run the same update statement, then though the update will happen, right? System, maybe I'll make it engineers. But this trigger won't be fired because I have disabled it. I don't see that thing right here. Now this value, if you'll see, it would be updated. But this trigger was not fired because I just disabled it. So this is about triggers, right? In the next class, we'll talk about the temporary tables, table variables, CTs, and some other functions. Once that all is done, we will start with some real life scenario, what happens in the organization, what type of things that you get, and also we'll move ahead to some more topics. So that is all for today's class. Let's speak tomorrow. Shweta, do you want to ask something?
No, Anu.
Okay.
Great.